Hey everybody, I'm Aaron Beeman with AMD, and I've been leading a strategic work stream between AMD and Epic Games on how we can advance an all-AMD virtual production ICVFX or in-camera VFX reference architecture. So let's start off and talk about the panel of folks that are here today that are going to talk about what we're doing. And by the way, I will provide a plug. We do have this demonstration set up in the expo on the second floor. So if you haven't already, please come by and play with the demo. But again, Aaron Beeman, I'm a market development executive at AMD and focused on advancing solutions, working through our ecosystem of partners. Would also like to introduce the rest of the panel. We've got Rajesh Ramachandran at the end here, who's president and CTO of Qube Cinema. Sam Racine is a VP of Sales Americas APAC with Matrox, another one of our partners in this POC testbed. Unfortunately, couldn't make it. Jeremy Hockman and Ryan Maeda. So Jeremy is with Megapixel and Ryan is with Epic. So actually, gents, maybe quickly, just a quick intro of who you are and what your. We're going to go into more in just a bit, but Rajesh, maybe a little bit more about Qube, just brief.
So Aaron, you got my name, pronunciation, and title right. So
okay, great.
Yeah, so Qube Cinema, we are about a 40-year-old media and entertainment technology company. We've done a lot of stuff in India, but in the last 25 years, we've been focusing on digital cinema as it relates to the digital distribution of movies to theaters. So we build hardware and software that's used in the playback of movies in theater. So we come from a very cinematic quality experience, and about 3 years ago, we built our own virtual production stage in Hyderabad, India, and that got us into this fantastic experience now, which we think we'll do for the next 20, 30 years. So that's where we are. More coming in the slides. So thanks, Aaron.
Yeah, thank you. And Ryan, maybe just quickly your role.
Hi, my name is Ryan. I'm a Pisces, and I'm one of the product managers on Unreal Engine. I focus on the in-camera VFX toolset, among others, and I'm excited to talk more about some new options here in the market for ICVFX deployments.
Great.
Jeremy, co-founder of Megapixel. We make a lot of visual technology that kind of streams from upstream video processing, LED processing, pixel mapping, video and data distribution, and then a lot of LED tile technology itself. And we use that for our own projects and products, and we license out to others as well.
Right. And then Sam, who's not here, represents Matrox. Matrox is a long-standing partner of AMD, and they are providing the network interface cards specifically for this reference architecture. So with that, let's just talk quickly about what the goal of this project was or is. It's to establish an all-AMD, and for those of you that aren't familiar, AMD is yet another semiconductor company. We've been around for 55 years, and we compete and collaborate with the likes of both Intel and NVIDIA. And like both of those companies, we make CPUs, we also make GPUs, and we also make these very specialized semiconductors called FPGAs, which are actually used in a lot of video equipment. So the goal here at AMD was to advance a reference architecture built completely on the breadth of our technology, our silicon offering, to support virtual production ICVFX. And most notably, one of the other requests from Epic here was to make sure that it was a modern workflow. And so what that means is this is completely leveraging Ethernet video over IP protocols, specifically a protocol called SMPTE 2110. And we'll talk about some of the great use cases even beyond just in-camera VFX. But this is, I think we're at a tipping point in terms of the use of this technology in video delivery and creation. So just a quick overview of the project. Back in June of 2022, AMD and Epic Games got together and outlined half a dozen strategic work streams that we wanted to engage in to advance certain capabilities. This team that we've assembled here, along with others, has been focused on, again, virtual production, And Epic had requested that we, as I'd said, advance an alternative to other solutions that exist in the market from some of the other companies that I'd already mentioned. So traditionally, production has been using green screen for many, many years. And then in post-production, that is then composited. That adds some latency to the creative process. Introducing LED panels allow for a lot of great benefits, not only for directorial and editorial uses, but also even for the subjects that are on the stage. They can actually see what their environment looks like. I think most everyone here is probably familiar with some of these advancements that we're seeing. And our guiding principle for all of this is that we've looked at and listened to feedback from Epic and from others in industry. Existing solutions are complex. There are a lot of knobs that can be tuned, and we really wanted to focus on making sure that this was a vetted and simplified solution that was vetted with all of the industry partners that we're working with. Also, AMD has always traditionally been known as a company that tends to be less expensive than other companies like Intel and NVIDIA. And so we really are excited about making this technology much more accessible, democratizing these workflows. So that's been a guiding principle for us. In terms of who we've been working with, this has been nearly a dozen companies working together, some of whom are represented on this panel right here. AMD, Qube Cinema, of course, Epic Games. Supermicro is one of our OEM partners who's been supporting the delivery of workstations. Megapixel, Red Digital, Arista with their 10 gig switch, or rather their 100 gig switch that we've integrated into the reference architecture. Blackmagic Design has supplied the studio reference monitors that are SMPTE 2110 compatible. Evertz has provided the clock signal generator, and then LG, the large LED display that we're featuring downstairs. Most of these companies are AMD consumers from one part of our silicon family or another, be that an FPGA, a GPU, or a CPU. And in terms of what is comprised of these render nodes, we've got 3 of these render nodes set up downstairs. We've got 2 of our very highest end GPUs. This is the Radeon Pro workstation class GPUs, the W7900 dual slot, so 2 of those, and then a very high performance, high core count CPU. We now make CPUs in the Threadripper Pro family that go up to 96 cores. I think in this case, Rajesh, 64. We're using 64 cores. And then Matrox provides the specialized network interface card that supports this video over IP standard SMPTE 2110. The reference architecture is comprised of really another guiding principle has been to leverage commercial off-the-shelf equipment. So this is a workstation from our partner Supermicro that integrates everything that I just described in that previous slide. So with that, Ryan, I'd love for you to maybe talk a bit about the performance that we've seen on our GPUs relative to others in the market.
Yeah, so this slide is a summary of I guess I would say like our own kind of internal way that we do profiling of scenes. So we have sort of X number of scenes. Like these 4 are the most common. So they range from like an older scene that was created in UE4 all the way up to things like the city sample that use more of the bells and whistles of the newer versions of the engine. And so we use this to like profile if the engine is getting faster or slower. Oftentimes we may find regressions as things are developed. And we always know what the baseline is. And then likewise, we use those to profile different hardware combinations. So at our lab in El Segundo, we have all these different combinations that range from all the different GPU options as well as CPU options and machines that come from different providers. So we have a base set, but then we have a whole bunch of other machines that we constantly run these tests on. And so one of the things that we test obviously are like the variations between the different GPUs. So this is kind of summarizing it in the way that we test it. It's kind of a lot of numbers. I think, this will be in the video and you can take a picture of it, but we generally test with 1 versus 2 GPUs in the machines, and the end display deployment, is adjusted accordingly. And then when the chart here says 2K versus 4K, that means we're running the interfrustum at 4K UHD, which is generally what we usually run the resolution at, and then 2K, which is like where we cut the screen percentage down to 50%. And so, like in this example, the comparison is between the AMD 7900 GPU and then the two most commonly used NVIDIA cards for in-camera VFX. So from having done this test in the past, like the 7900 is definitely a leap up. Like numbers wise, it comes out like fairly comparable to the NVIDIA A6000, but still below the Ada Lovelace current gen. But it's just reflective of the option of, from our perspective, the performance is making the AMD option potentially viable or at least comparable to what people are accustomed to. Like at this point, like the A6000 is probably the most commonly seen card in camera VFX. So it was important for AMD to be able to reach that benchmark. And then price-wise, in the corner, do you want to maybe speak to the?
Yeah, sure. I mean, these are just suggested resale prices, publicly available prices for all three options. Again, AMD tends to be less expensive, and as we work with resellers like Qube, not only are we looking at how we price these to be competitive and enable new market opportunities. But what we've done is we've established a test bed at Qube's offices in Hawthorne, actually very close to where Ryan works from in El Segundo. And we'll continue to evolve this test bed. We'll continue to introduce other solutions and optimize configurations to enable scalability. And so with that, we may even look at some of the consumer range GPUs. The W7900 has a total of 48 gigs of GDDR on each card. And I don't think Rajesh or Andre, we're not even really saturating that.
No.
Right?
Not in the tests that we have done so far, yes.
Yep.
Yeah.
So we're going to continue to explore ways that we can reduce cost, because we think that we're at a point now where we can make this technology a lot more accessible. Which is exciting, not just to emerging markets like the Indian film community industry that Qube Cinema serves, but even larger market opportunities that we see, like the creator markets. So, folks that are making money from home streaming on various platforms, we see opportunities there. So we'll look at, again, running through this test bed, different configurations that can continue to drive down cost of entry. All right, so Rajesh, I'd love for you to talk about the demo that we've set up.
Sure. So if you go down to the expo, you're going to see a 12 feet wide wall. And the way we have configured is we are using 3 render nodes. So we have one render node, which we call the camera render node, that's rendering the inner frustum of the camera. And the wall itself is then divided into a left half and a right half for the viewports, or the outers, as they are called. So if you actually move to the next slide, thanks, Aaron. So you'll see that the 3 render nodes, we actually have a very identical configuration on these 3 render nodes. So you have the camera render node rendering the inner frustum, and then it very, very quickly sends that inner frustum frame to the 2 nodes that are rendering the viewport. So the left viewport node takes half of it, or whatever part of the inner frustum is overlapping with it, composites it on the outer viewport and sends that out. And the right also does the same thing. And all of them do them in very precise, in a very precise manner, because they are fed with the PTP reference clock that comes from an EVERT system that's in a test bed. We actually have it hooked up to a GPS antenna. Here it's actually generating an internal reference, and all of the network exchange happens through a Arista switch that can go up to 100 gigabits per second. So the 3 outputs from the render nodes go into the Arista switch, and from there they take a 100G path into the Megapixel SIMT 2110 input. And we have set up the Megapixel to pick the right rasters from the two viewport nodes to create the right framing for the wall that we have here. The wall we have here is like a 2K wall at 12 feet. So that's what's going on here. So, and then we have a director node, which happens to be a very similar configuration, but you could do that out of a laptop and would get all the same performance. And for the camera, we're using a Red V-Raptor X. And what's interesting about the camera is that it actually can take a PTP in for sensor sync. And so what that means is the camera does not require traditional gen lock input that the camera could. And the camera, in fact, can even do a gen lock output, for example, into the tracking system, because Moses still requires gen lock, which they are working on a PTP, at which point we have a pure network and linked facility and not require any video interfaces to be going through. That's the signal diagram. Please come to our booth and you can really see this. And we have separated this out into a render rack. And if you look at the back of the render rack, you will only see power and network. No DVI, DisplayPort, HDMI, or any video interfaces coming out of it. So as engineers, we're very excited to see such configurations. And we'll go into some of the 2110 benefits.
And there's additional capacity within this system, right, to support multiple cameras, right? Yeah. We brought a single camera, but certainly could support an A camera, B camera. We'll talk about some of the use cases for 2110, including remote production, right? Because this is all done over standard Ethernet protocols. So Rajesh, maybe if you could go into just a bit of a deeper overview of Qube Cinema and your strategy, where you're focused, that would be great.
Sure. So I said we're a bunch of engineers, but all of us huge movie buffs, so we try to get as close as possible to the storytelling process. We've realized that we can't be on the other side of the camera, so we stay behind the camera, and we've done a whole bunch of things in the last 40 years that we've been in business. And the next slide shows the ecosystem that we have built. It's a bit crowded because we kind of touch every aspect of the storytelling spectrum. So we have products and solutions for filmmakers, distributors, advertisers, exhibitors, audience, and also for broadcast and newsroom. So we touch all of those areas. A big portion of our market, as I mentioned earlier, has been in India. It's the first 15 years of our existence. But in the last 25 years, we have expanded globally with the digital cinema distribution piece. So we distribute every movie that goes out theatrically, all Bollywood movies and all Hollywood movies to various territories around the world. And virtual production, as you can see in the bottom left corner, has been a recent foray into storytelling, and most exciting because it moves us, because our bread and butter has been distribution. So it's like, people remind us that we come into the picture after all the creativity ends. So we wanted to get more closer to the creative process, and virtual production certainly has gotten us much closer to that. And to learn virtual production, what we did was, you can see in the next slide, we built the first feature film-focused virtual production stage in Hyderabad, India, with a studio partner, Annapurna Studios. So this is a 60 feet by 20 feet wall with wild walls and a ceiling, and has already been used for a bunch of Indian feature films and commercial shoots. So that's what we're doing, and with thanks to Aaron, he brought us into a product development opportunity here, that we were able to build this All-AMD platform. But our larger vision actually is that we see that ICVFX is a good use case for compute-intensive platforms. But to give you an example, like even our stage is located in a facility that does a lot of VFX work. And today what happens is that they have, at best 12 hours of shoot in a day, and the entire render infrastructure sits idle for 12 hours. And they for them to do their VFX renders that uses a completely different set of tool sets, different operating system, they can't even touch these, and they don't want to touch them because we all know that in a non-SIMT 2110 world, the architecture that we build out, because of the various pieces of equipment that's interoperating, and particularly like the HDMI interface that we use, is a very brittle interface. So you don't want to reconfigure them and not be ready for your shoot the next day, right? So it's much better to leave them idle for 12 hours so that you know that at 9 a.m. your shoot starts. But we are working towards a software-defined architecture where all of this can be automated out. So this is still work in progress. So you could use that same render infrastructure for other workloads within your facility. So that way you're amortizing your cost over various other workloads. So, and 2110 makes it very possible because you're not now dealing with fixed video rasters. You're not dealing with HDMI, matrix switchers, and all those things that were maybe cool 10, 20 years ago. With all of this being available on the network, there's, of course, the flexibility of reconfiguration, remote work. Like one of the potential that we see now is a very seamless integration of remote direction and remote preview of what's happening on a stage. Again, just grabbing the stream off the network, transcoding it, and sending it over the cloud to people that are in remote locations to get real-time previews and so on. So that's the philosophy and the future that we are going along, ICVFX being our first use case that we are targeting.
Great. Thank you, Rajesh. Jeremy, would be great if we could have you maybe talk a bit about Megapixel, your history and your contribution to the project.
Yeah, absolutely. I'll step through a few slides of kind of what we've done throughout the history of virtual production as well. As I mentioned before, we create visual technology. So everything from image processing all the way to the chemistry and the LEDs that makes photons come out of them. So for the last 20 years, our engineering team has been very involved in some of the pivotal moments of ICVFX before it was called that. We first started putting LEDs onto film back in 2005 for Zodiac. This was the first time ever that video-driven panels were used for key lighting, and this was all timed to SMPTE time code so that it was repeatable and dependable for take after take. Then we started doing some larger vehicles. We realized that we needed to have more color accuracy and the ability to do keying and these sort of things live to the video. At the time, and again, this is a good example of how you can do this on a low budget. I was using a laptop and an external monitor, and there wasn't an Unreal Engine available to do these things, so I was having to write GPU shaders overnight in the hotel room. I wish I was doing this on Unreal today. Then we started building bigger boxes to get more incident lighting. In 2016, there was a nice pivotal moment where more of the mechanics of LED became more accessible because LED is quite complex and physically heavy to rig, and the older sound stages aren't made for hanging a lot of weight. So around this time frame, we had introduced carbon fiber manufacturing into the LED industry, and so the aerospace materials allowed us to start hanging really, really large arrays that were not so heavy, and so this allowed us to scale up a lot bigger. And then in 2017, this is the first time that LED was able to be used in camera without getting replaced. So we went beyond just the fill light and the key light, but actually went to LED. And even back then, this was 2 times 8K resolution. So the resolutions already are fairly large. And then in 2018 for First Man, this is the first volume, I guess, as they're called today, where we built a very large rounded screen that was used again in camera very successfully. And this was both shot on film and digital with a mix. So color consistency and capabilities were really, really important. And that kind of got baked into a lot of our processing. And then kind of putting all of it together, one of the most modern stages in the world is Trilith, a Lux stage in Atlanta with Megalopolis that just released last weekend. So today we have Helios as a 1RU appliance. This is a part of the test bed that's downstairs in the demo. And I won't go into all the details for this, but basically we think about video today as more of an IT problem than a video connector problem. So we're super happy to see SMPTE 2110 being adopted more and being able to do more interop with partners. So having 100 gig capability direct in means that the Unreal texture can basically be mapped directly to the LEDs without having to be going through video switchers and connectors that can fail and things like that. And so it's not only about the integrity of the signal and being able to make sure that it gets there with less latency, but also because it's part of an IT network now, it means that we can actually see the signal and understand what it's doing along the way for troubleshooting and analytics, which is really important. And when you start getting into remote productions and things that that might be in data centers as opposed to on-prem with you, these types of things are hyper important. And then on the receiving side, so after all of the data goes through the Helios processor, we have a tile side processor called PX1, which actually lives inside of every single LED tile. And this has our OS and software running in it to actually light up the pixels. So even if it's a tile from somebody else, it has our card inside. And then we're excited about things that go beyond as well. Stages are very, very cool, but Unreal is getting used in more architectural scenarios as well. So just as a little Easter egg, this is an install that we did actually quite some time ago, but it's 27 4K surfaces that are a minimum of 1 mile away from the machine room. And so fiber cabling and IT and IP infrastructure for that data is hyper important. So we're really excited about all of it.
Great, thank you. All right, so Jeremy, thank you for providing some extensibility of what we're doing here for ICVFX into some other adjacent market opportunities. I'm going to take a couple of minutes and run through Matrox's contributions, and then from there we'll have a bit of a discussion. I've got a couple of questions, and of course we'll open it up to the audience here if there are any specific questions that we can answer. So again, Matrox, longstanding partner of ours, like everyone else on this panel here, and they have produced the network interface card, right, that is integrated into the render nodes. Matrox is a company that's heavily used in the broadcast industry, and they've been one of the early adopters of these video over IP protocols. So they have native support for SMPTE 2110 in their family of NIC cards. This is a picture of their most recently released 100 gig card, the LE6, which was announced at IBC just a couple weeks ago in Amsterdam. We're using, I think, the LE5, which is a 25 gig card in the test bed downstairs. But this card's capable of supporting 8 UHD, P50 or 60 inputs and outputs, can support up to 2 8K inputs and outputs. Ample support for audio flow from 1 to 64 tracks. In terms of latency, is subfield subframe transfers between I/O within the card. We've got some dense block diagrams. I won't spend a lot of time going over those, but this is essentially another representation of the reference architecture that we're demonstrating downstairs. This is showing multiple render nodes, and in this case, 2 render nodes for the viewports and 1 for the interfustum. And all of that running over an ST2110 NIC, and then going out to the Megapixel LED wall processor. We've partnered as a team, as a test bed. So this is a collaboration with Qube and Epic Games and Matrox in particular to develop an Unreal Engine plugin for this particular card. The card that I showed you, again, has a number of use cases in broadcast where perhaps a UE plugin wouldn't be needed, but because of this project, we were able to advance as a team this plugin, and that's soon to be released, as I understand.
Yeah. So the install downstairs is running a pre-release version of the an updated Matrox plugin for Unreal that will add the SMPTE 2110 support. So think there'll be a follow-up and some updated documentation on how to get it pretty soon. But it's great to have a functioning setup downstairs. There was actually a couple things that we're going to need to work with them that's kind of our fault that we changed in 5.5. We should make the plugin better, but it does require a little bit more work. So we'll be kind of dotting the I's and crossing the T's with that. And the Matrox plugin should be available to people very soon.
Yeah, and that's the nature of a POC. That's the nature of a test bed. It's been very collaborative, a lot of great learnings. We'll continue to improve the offering. And I'll put a call to action out to those of you in the audience here. If you feel that you could be a consumer of this technology, I think we're at a state now where we're open to engaging. So if you have a use case you want to run, reach out to us. You can reach out to Qube directly. They have the test bed set up down in Hawthorne. Or reach out to any of us. We'll make sure to provide our contact details after the session here. And so the NIC provides frame accuracy throughout the entire UE pipeline, coordinating the delivery of frames across the various GPUs to show a cohesive display. And it will repeat the last frame if the engine can't be fed fast enough. So they've got some forward error correction integrated into their plugin to make sure that you've got just very smooth operation, which we've been seeing the whole the last couple of days here, which is great. Trust me, I've been through a lot of these tech demos, and they don't always go as smoothly as this one has. So that's great. So I'm going to pause here. We've got about 20 minutes left. I think we're going to take maybe about 10 minutes. I've got a couple of questions I wanted to just pose to the panel here, and then we'd like to open it up and have a discussion with you if there's interest to dig into any of these bits. But one thing I'd like to ask the panel is, some of the, we've looked at like a fixed single site deployment of an ST2110 network. Rajesh, what are some of the other use cases for 2110 that you're seeing or that we're hearing folks bring up today or this week at UE Fest?
Certainly. So we had a very interesting live performance use case that somebody from the live business was talking about, immersive entertainment. ICVFX is like I was saying, for us also, it was also like a gateway, but it seems to open a lot other opportunities, just a very refined way of working. And one thing that our focus again has been when it comes to technologies to make it work for India. And what we realize is that if you make it work for India, then it works for the rest of the world, because India is a very cost-sensitive market, but very prolific, right? So we do, for example, in a typical year, 2,000 titles that get released theatrically, and a whole bunch that get made and don't get released at all. And we joke about how the Indian market wants Hollywood quality at Indian prices. So this has always forced us to come up with alternatives, always forced us to think a little out of the box to bring the cost down. And our focus is largely this year, both in the broadcast and in the film production space, to commoditize SMPTE 2110. As much as magical or as great, as refined as that architecture seems to be, today it's more expensive than traditional video networks. Everything from the NIC to the switch to, and then the skills that are needed to maintain a network. PTP synchronization, all of that requires a certain level of cost and competence. And that's what we are focused on. So there are great options today, but also trying to see if we can open this out to more commodity off-the-shelf NICs that have some minimum features for PTP timestamping, and thereby open the choice. And then we were very pleasantly surprised while working on the plugin to look at the source code that already was in place for the existing 2110 implementation that Unreal has done. Looks excellent software engineering quality there that we'll use as a base to open this out to other NICs in this space. So,
did our engineers pay you to say that? It's worth it.
So Rajesh, one of the use cases we were discussing too is, given that this is running over an IT network, this now opens up the ability to support things like remote production. So maybe if you could talk a little bit about that use case.
Yeah, and given that a lot of I know that Mandalorian was a very well spoken about project, but the pandemic seemed to be the genesis of this explosion and interest that we saw for ICVFX, and we are seeing that directors and production designers and a bunch of the crew are now comfortable working remotely on Zoom calls, and being able to then tell them that we are actually providing the exact feed that we are sending out to the wall gives them a level of confidence, knowing that it's not some other sideband video that we are tapping out and giving it to them. So and now just being able to just take it out of the network, send it through a transcoder, all becomes so much more possible. So that's remote preview, remote direction are all opportunities we are very excited about.
So director can be on set, but editorial can be in a different building, a different location, halfway around the world. I think that's one of the exciting opportunities that this is opening up. I mean, content is king, and being able to increase the velocity by which you're creating content is important. Jeremy, let's talk a little bit about maybe diving in a little bit more around the extensibility of this tech into other industries. You did talk about, I think you had like a hospitality use case, but let's talk a little bit about some of the great things you just did at the Eurovision contest.
Yeah, we're seeing 2110 being amazing for of course, film production and remote production. Broadcast has gotten great adoption, but also retail deployments. Eurovision was a wonderful broadcast that was actually the first ever live broadcast using 100 gig 2110 for all of the infrastructure. There was a 1.4 terabit network that was running everything from server content to LED processing to all of the tile metadata. The whole network is bidirectional as well. It was running Pyro, there was NMOS control, cutting cameras. And so there were actually camera shots and things happening on stage that would not have been possible with human operators because you can't react quick enough. And so there were really, really cool things creatively that could be done because we were able to allow the creative director and people operating equipment to actually focus on the intent of what they wanted to see happen as opposed to physically operating it constantly. And so that was really, really cool. And then on top of that, moving from last year being HDMI to this year being 2110, the footprint of the video racks for the entire stage just went on the other side of a catering table. It was like 6 racks, loaded with Ethernet switches and some equipment, and that was it. So the amount of equipment that was on this year's show would not have been possible if we didn't do 2110. So that was really cool. And the thing that I'm very excited about as well, given that it's leveraging the IT infrastructure, is that we get to see into every single piece of equipment. So as Rajesh was mentioning, the fact that everything is now like flat on the network and we don't have a BNC connected to a box that's connected to another box that's connected to another box, we now know what's on the wire. And instead of just saying, okay, I see that a video signal is present, we know that a video signal is present, we know what kind of signal it is, we know what's in the signal, but then we know the next set as well. We can start looking at temperatures, we can start looking at analytics, we can look for frame drops. And so in a volume, for example, that's Mandalorian size, this is massive, massive cost for actors, all the talent and the scenic and the people supporting this. And so if you see something glitch out of the corner of your eye and you can't pinpoint that immediately, it's very difficult and costly. And so having all the bidirectional data lets us actually dig in down to the component level and understand what's going on too. So that day 2 cost of ownership is actually just as important or more important as the initial setup.
Great, thank you. Couple minutes, Ryan, in terms of next steps, you alluded to this a little bit, but how, I think we want to take a couple of approaches in terms of how we make this accessible. Can you talk a bit about how anybody who might be interested can get access to what we've done?
Yeah, like plugin wise, there'll be postings. We'll be updating the documentation for our 2110 setup to go over the additional options in the same way we do for something like the SDI options where we support multiple cards, just to explain to people what the differences are, the subtle setup changes between them, and then I think that talking to Qube and Rajesh to work through them on access to the cards from Matrox, since Matrox always works with partners. Rajesh is going to be a really good resource to help you, get set up to potentially buy the cards if you want. But yeah, I mean, like as with 5.5 going out, like I said, there'll be a few adjustments to make to the plugin before it hits the market, and then it'll be out there. You'll be able to use it for any of these different use cases that we've already brought up, and then also on the Matrox side for any of the broadcast companies that are already kind of invested in a Matrox infrastructure. The 2110 option will become available to them for their Unreal output.
Excellent, thank you. And then, of course, we're working with Qube Cinema as initially a reseller of these solutions. So, please make sure you get Rajesh's contact information after this discussion if you're interested in engaging in a POC or looking to do a fully integrated system. All right, well, I think we're past time. Thank you all for your engagement here, your questions. Hope you found this interesting. We'll stick around if you have any questions, and if you like, feel free to reach out to us downstairs at the demo, and look forward to continuing the conversation. Thank you. And thank you to everybody.
Thank you.